Okay, so here we go. This is the Arduino Pro Mini. This is the microcontroller I'm going to use to control the analog filter. This is one of the modules. It's actually from the Shruti, and it can be controlled via its connector. And you can see here, focus you fuck. You can see the connections are amplitude, resonance and frequency. These are the ones we're going to be using. So for those, Arduino has PWM outputs, and the first time I tried it I had issue because the frequency was far too low. So the audio was garbage. Then I created a prototype board with some capacitors, and that actually smoothened out the PWM square output to a nice even voltage. And here I have the output. The lower one is running at supposedly 15, but it's actually 32 kilohertz. This should be quite high, but still this will have to be smoothened by the capacitors. The first time I tried it, I used the ordinary frequency of the Arduino, and this was far too low. So I decided to dig up on the internet and find some nice cheat codes to really get some high frequencies out of the Arduinos. The one thing that's a bit problematic is that the timer 0 PWMs have a different frequency than the others, so you can see here it's floating. But no matter, it's still okay. I'll use a nice capacitor just to even this out, and this will be fine. Here's the first prototype board. I just made a quick board to connect the Raspberry Pi, the Arduino and the PWM pins. This is the capacitor and the resistor RC filter, because the PWM signal is just too slow and it interfered with the audio, so I had to smoothen it out to a nice value. And this is the power supply section. It is intended to be supplied by 12 volts. There's the capacitor for smoothing and a nice regulator to convert it to 5. From the 12 volts, it is also intended to supply the analog modules, which have their own 12 volt input. I could directly connect them with a 5 volt signal, but I want to keep them intact for possible other use of these boards.